Yeah, my life is lovely now, I'm focused on me. You said you were about to die, I guess the car is on E. But see, I ain't even tripping, cause I just chose to believe that somebody gon' come around and give me just what I need. I don't wanna see you flying, see you looking down and out, coming to me crying, saying you miss having me around. Gave you chances and you blew it, you so easily influenced. All the times you told me beat it, now you gotta face the music. I'm saying
I know that I gotta stay away from all your games, yeah. I know that I found somebody else to love me one day, and you'll realize the grass ain't greener on the other side, no. You did me dirty for the last time, so now I gotta say goodbye. So now I gotta say
hosting us here in this wonderful place with these wonderful snacks and beers and top-notch speakers. Speaking of today's agenda, we have not 2, but 3 talks. First goes Veriff's own teeth with evolution of testing. Then we have as well from Veriff Revo lightweight talk, but nonetheless very important, of course, on sleep. Well, that's pretty much. Huh? Yeah, it's prior sleep on sleep, exactly. So at this point, please welcome on stage Teeth with the welcome word and kicking off.
Very good, thank you. So yeah, welcome to Veriff, guys. Really glad to host you here, and finally we get to develop here. I'm sorry about our sort of all hands area is a little bit cramped, but even more you feel intimate and can sit close to your neighbor and exchange ideas on the breaks. So yes, I'm gonna cover the evolution of testing, a little bit about Veriff in the beginning as well. My journey has been through several companies as a head of quality engineering, and now at Veriff my title is VP of Engineering, but currently I'm coordinating client testing, for example. So that's a little bit, with the startup vibe, you do this and that, but you do what is necessary today, and tomorrow you're going to be doing something different. So that's sort of a fact of life in startup scene anyway. So what is Veriff? How many of you had the possibility to use Veriff as end user, possibly? A couple of people, right? So basically we turn physical documents into digital identity per session. So let's say you have a bank and they want to get you as a customer, and they need to verify whether you are you and get your document data to their databases. So they go through the flow, you select the document, you do the selfie, you show the document front and back sides, and in a couple of minutes bank gets your information with a verdict whether you were actually you. And that's quite important, because these days trust is everything in internet. So you can be a dog still in internet, or even worse. So Veriff is here to really prevent our identity theft, and that has been tried many times. We are able to catch those guys who are trying to impersonate somebody else. We also deliver this hard requirement that some financial institutions have, what goes to know your customer policies. So they need to do certain verifications repeatedly on their customers, and make sure the customers are really who they claim to be. Also, if you are online marketplace or cryptocurrency exchange, you do some marketing campaigns, and many people try to abuse your marketing offering, for example. So Veriff also helps there to make sure that each person goes through their flow once and not twice or 10 times or 100 times. So that cuts a lot of costs and risks for any kind of online provider, basically. And all that results with a higher level of trust between people who are remote and are interacting not physically but virtually, digitally. So Veriff is really here to enable the sort of be as you would be face-to-face with your company, but you can be actually anywhere. So that's the Veriff product. We also have lots of competitors these days coming up, but we feel always that we are one step ahead of them what goes to automation and accuracy and conversion metrics. So doing very well. All right, a little bit about myself so you know who you're talking to. I worked at Skype as head of quality engineering for 8 years, and then did a couple of side gigs, but ended up in Pipedrive as a second quality person with a quality title, so head of quality engineering at Pipedrive, and then continued to Veriff. I also have a pet project, Põhjala, so that's the, thank you. It's not so pet anymore. It has grown to be actually pretty big, number 4 in Estonia, what goes to liters of beer or revenues. But we also got nominated as top 100 breweries of the world out of 30,000. So our position was 57th on 2018, and soon we're going to get 2019 numbers, so we'll see. I also do a little flying, have a little over 1,000 jumps, so during summer times on weekends you can find me at Rapla Airfield. Well, I fly this wonderful Pilatus Porter. Occasionally you also do some jumps, but not that active anymore. All right. So, of course, I have to advertise our podcast, which got launched on November last year. So there, me and Priit Liivak and Sergei Anikin are talking about software engineering. It's in Estonian, so those who need to practice their Estonian skills can chime in and listen to that. But we specifically wanted to do it in Estonian, and we have had wonderful guests, and also the listener base is about well over 1,000 people regularly, which is great. Thank you for that. Alrighty. So, evolution of testing. I first sort of encountered testing in 2005 when I joined Skype. They said that, I don't know anything about testing, but they said you will learn. So I had to learn, and I did a little bit of hardware testing as a Skype certification program, but then quickly after 1 year turned into being responsible for whole testing at Skype. And it was a great ride. We did lots of good stuff back when Skype was still a cool thing. Not anymore though, yeah. Microsoft ate it. All right, but I did a little bit of research about testing, and now is my opportunity to get you in the mood as well. So if you look at the history, and if you specifically focus on computers and information, like computer age, let's say so, then really in the beginning it was sort of, we couldn't differentiate testing from debugging basically. So it was early days, computers was as size as a room, and then it sort of started to develop slowly, but somewhere at the late early 70s, etc., it sort of turned into people actually started to write requirements, so they wanted to validate whether this application is actually meeting those requirements. So testing was sort of a demonstration that yes, this application actually meets its requirements. And then there was a short period, according to this guy who researched that in depth, Keplerin and Hetzel, so where there was a movement that we should destroy the software, we should basically kill it because it's not working properly. That negativity, of course, didn't fly so well. And I think they did a little bit of disservice for testing in general, because that negativity sort of carried on into the future decades as well. But it turned into the sort of evaluation of whether software is actually is able to work as intended, and people are using it. So personal computers got involved, more people started to use software, and actually then it entered into the prevention mode where it is today, where we actually want, through testing, to validate that anything that users are seeing is actually something that we wanted them to see. So now, fast forward to recent history. On the below the line, you see the sort of a methodology development. Above the line, you see the approach to testing, if you will. So in the 80s, everyone used boxed software. You had floppy disks to upload it into a computer. So everything that needed to go out, you can't really call back, you know. It's out there on the floppy disk, so it worked or didn't. And there was no way to upgrade it almost. It was a really a big problem then. In 90s, that's where I got involved with computers in 95. Already people started to evaluate different approaches to software development, so they realized that this waterfall methodology, over-the-wall drawing stuff didn't really work. But also they started to evaluate automation opportunities, so they realized that all this manual testing is not getting us where we want to be. And in 2000s, basically Agile took over and people realized that we can actually release software more than just once. And automation also developing new frameworks that helped automation to move forward. And yeah, last 20 years has been a really interesting ride in terms of testing. So from development, everything sort of merged together. You know, the developer became responsible of so many more things that they did in the early days. So DevOps and CI/CD virtualization was a real thing, and automation also developed further to enable scale and cover more frameworks, more languages. So that was interesting, right? Definitely. When I joined Pipedrive, coming from Skype, I basically had to relearn everything that I knew about testing in context of CI/CD and DevOps mentality, etc. So. But what is the future? And nobody can tell, but yes?
Why did you have to relearn everything?
Because
Are you doing it wrong?
I'm actually going to cover that a little bit later. We did lots of things that normal companies wouldn't do. Because you understand the impact was immense, you know. We had tens of millions of users online. You did something wrong, boom, everything went up, you know. So you had to invest into testing a lot. And we did that. But in future, I think the machine learning is coming into play in some way or form, probably. So many human processes are automated through machine learning already. Machines are able to learn, they're able to generate data, and they're actually better at it than humans. So we're going to see probably lots of sort of autonomous test bots, etc., replacing humans here and there. We're going to see a lot more testing done in production in form of canary releases. And the first sort of steps when you release something, first tests will be done in production. And if everything goes well, you basically continue with the deployment to other servers. They call it sort of a collaborative smart testing. You can Google for these two guys. They have a pretty good idea of what's going on there. So, yeah. Really interesting times from that perspective. Okay, this is my own sort of a take on testing. When I'm looking back, I see that there is a sort of a testing as such has been like really a quality control function, which evolved into quality assurance function, which basically means that you set up the processes in a way that everything that is built using these processes will become high quality. But then it went to the sort of quality engineering, where you actually, the testing moved closer to production and more automation was introduced. And hopefully it will evolve into engineering quality then, although I think it's not going to be the name that they call it in the future. So we'll see. Interesting times again. Yeah, another perspective presented by this Petty cohort in 2003. He basically looked at testing schools of thought and tried to sort of qualify different types of approaches into sort of schools of thought. So analytical school is something that you do in academic scenes. Everything is very technical, very sort of accurate. The humans are basically not involved almost. So you probably use the analytic school when you test medical equipment or satellites, for example. So, and then the standard school is there to measure the progress, like how well we are progressing in software development. It actually invests into cost monitoring as well, and making sure that all the repeatable processes always are carried out in the same way. And then quality school is more like process-oriented. It's like policing developers, and quality function is acting like a gatekeeper. We've seen that a lot, so there is a little bit of overlap between standard school and quality school. And then last 10 years, I think the Agile school has been there, you know, Agile software testing, etc. People talking about it, which is more like focusing on the user testing, and the Agile school is basically trying to use testing as measurement of completeness. So whether a story is completed or hasn't been tested, it's been not testing the whole framework, but one story only or one task only. And of course, in Agile school, there is a heavy focus on automation because that cuts time, which means that we can get everything done during the sprint. And last but not least is the context-driven school that is trying to use the psychology, and I focus their efforts where it makes sense, so that they really want to test things that are most important for the user, and very sort of focusing on the user and stakeholder sort of context there. So and try to also a little bit emphasize the size of those schools of thought. So I think many companies are in the quality standard school these days. All the startups are in the Agile school. Some are evolving into more sort of context-driven school as well. So yeah, I forgot explaining the axis, but you got it already, I guess. So the y-axis shows the depth of testing, and then x-axis shows the productivity and throughput, how fast you can put things through using these approaches in terms of testing. And then I also added a couple of companies here that I have personal relationships with. So Skype was really a big part of sort of a standard and standard and quality school, while Pipedrive was purely Agile, and Veriff is somewhere moving towards Agile. So we test a little bit here and there, but we really measure or we use testing to validate the completeness of the task and then fix it later when it doesn't work. All right, so we probably are moving towards the context-driven school, because in our business, mistake is a really expensive one, specifically what goes to dealing with personalized information. So we have no way of losing any personal records that people are putting through our system. Okay, yeah, so also wanted to give you a little bit of background what was done in Skype, Pipedrive, and now in Veriff. So you all already know that back in the day, Skype was a downloadable application. It was downloaded by millions, and actually it was good because the whole thing ran on people's computers. We had very little servers. We used peer-to-peer protocol to basically build up the Skype cloud. And what was good about Skype was, I mean, why it was successful in its own time was that it actually just worked. I mean, the UI on the computer screen and all the networking, it just worked. It freely passed all the firewalls, no issues there. And that wasn't so for other VoIP solutions back in early 2000s. What was good about Skype was that the growth was so fast, and the revenues also sort of matched up very quickly. So the scale enabled us to invest a lot into testing. We had basically 2 teams testing same release candidate parallel in Tallinn and Ukraine over like 24 hours. And we also utilized a little bit of the follow the sun principle, where one team finished, the other team in US picked up the process and continued. because we already back then were quite a global organization. So I invested millions of euros annually into testing in terms of salaries and investments into outsourcing as well. It's a luxury because usually companies are not in that place. But every mistake, every delay or additional second that people spent, I don't know, if you wanted your call to be connected, you know, how quickly it was done, it was multiplied by 30 million immediately every call. So the waste or the impact was really big. So that's why we actually invested a lot into testing. So a couple of interesting things that we did already, like 2006, 2007, 2008. One of the things was log analyzer. Skype was basically an application in various platforms, but it utilized the same core library, and that core library logged a lot of data about session, about its own health, etc. So we basically consolidated all this logging information into our servers and had some nice parsing algorithms running on it. So we knew how much each library version consumed memory, CPU, how it behaves in different networking conditions, etc. So all that data was centrally gathered. So you just had to enable your Skype client to work in debugging mode, and then this data started to flow to us. The other cool thing was the automatic call system. So it was a full room of small computers calling to each other. So when we released a new release candidate, we put it into automatic call system, and it generated about 10,000 calls an hour. So 10,000 executions automatically, where we were able to monitor how it behaves, and then we were also tweaking the networking conditions and see how it behaves. So there's lots of sort of this black box testing that was automated, but since it was automated, it didn't cost so much for us. So all the user and experience testing was outsourced to outsourcing companies providing these services. But well, if you still remember using Skype, it actually worked pretty well because we built Skype using Skype. So we were our own dog fooders, so we had to eat our dog food every day. And most of the Skype folks in offices, they run the latest versions, of course. So every moment we realized that something's wrong, bug got logged, and I think the average bug count was, well, we started with 3,000 and we had continuous bug count around 1,000. So it didn't shrink below that anymore. So, well, but it still worked for most of the people, right? Yeah, so some folks came into Skype, wanted to use some other tools that very quickly realized that it's not an option. You have to use Skype, and email even got well, later people started to use email as well, but everything is happening in Skype chats. Also, a very interesting thing in Skype was that 2009, when we did the agile transformation, so Skype was sort of a chaotic big startup throughout its like 2003 until 2009. But then we really took ownership of services. Teams got formed, teams that are like have standardized interfaces between them, and also the testing was going through this agile transformation. And actually, it's remarkable that many things that we did back then, when Microsoft purchased Skype in 2011, it was actually something that they took over from Skype. So that is sort of a cool thing. Then later, they of course killed the testing function altogether. So all testers were renamed to something else. But then I was already gone from that organization. So. All right, so a little bit about Pipedrive. Like I said in the beginning, I was the second guy with the quality title. So I joined, we had one UI automation engineer, and that was it. So we had a sort of a situation where we didn't have actually testers to test, because, I mean, of course, the product owners tested and developers tested, but there was no focused testing folks. We realized that we're not going to actually hire them, that we're going to actually push teams to increase their testing automation to a level where it's not even necessary, right? So we very quickly, in about year's time, like 2015, 2016, we got into a situation where there was no manual testing even for larger deployments. All the daily deployments, of course, were not manually tested. There was a strong enough automation suite to cover the functionality testing and integration testing. So, and very quickly, those service owners who had certain parts of the application, their success was measured by test coverage or code coverage, basically, on unit level, integration level, and UI test level as well. Yes?
Question regarding automated testing alone being well enough to ship big features to production. Imagine that your yeah, thank you. So imagine your end-to-end automation test suite passes, and everything that should work works, everything that should be visible is visible, but it's just plain ugly. How do you capture that?
Yeah, so this, of course, was done because when the product team works on their feature, they are doing daily releases into test environments, right? And then product owners and developers are looking at, and designers as well, looking at those. But what I'm talking about here is things that sort of are deploy ready and how to get them to production. So then there wasn't any more humans looking at it, basically. So because of the high coverage of integration and unit tests and the UI tests, we were pretty confident that actually we can continue along these lines. Later, like 2017, we realized that we actually teams need some kind of a quality person still who would do a little bit of planning, like what kind of tests to write, what the kind of flows to cover. So we introduced the function of quality analyst in the team, and they then worked with the teams to basically help developers to pinpoint the areas that need automation. Yeah, actually, in Pipedrive, the frequency of releases was quite astonishing. When I left 2018, we did 60 deployments per day, about 130 engineers back then. So it was, we actually had deployment queues. So if you needed to deploy something, you had to wait a couple of hours before other deployments were able to finish their testing cycles. So normal sort of so we had a couple of monoliths and a number of microservices, but when you deployed monolith, it was about 15 minutes that you had to wait for it to go to the CI and execute all the tests. But in Pipedrive, we discovered one cool thing that almost by accident, actually, which I can't really name too well, but I call it cross-layer automated regression suite. So we have in Pipedrive we had a PHP backend, basically an API that the web app runs on top of it. So we had the UI tests testing web app, and we had integration tests testing API endpoints. And across various endpoints, the coverage varied, basically. But then we figured out, hey, why not to run the API into sort of a debugging mode and execute UI tests and see how is the endpoint coverage from the UI tests perspective. So we realized that, all right, it's actually somewhere totally different in terms of endpoints what goes to the tests that have been created to test those endpoints. So then we realized we have actually pretty good coverage. So each time we deploy backend or web app, then we execute both tests suits, and we are good to go. So that was a wonderful discovery. There was, of course, some areas that were a little bit gray, but with that combination, we then optimized the test suite running speed, doing lots of parallel executors, basically, and it was done in about 8 minutes. So lots of test infrastructure, actually about, I think it was 15% at that one time, that was only doing testing. And then out of all infrastructure, 15% was allocated to testing. So that was wonderful discovery and saved lots of gray hair for us and enabled to move fast. Well, in Veriff, today we have a highly virtualized set of microservices. And virtualization is important here because everything runs in Docker, is hosted in Kubernetes, that lives in AWS. We are able to deploy very freely because those microservices only do one thing. If it doesn't work, we can roll back. So we are doing lots of this sort of deployments. Maybe we are at like 10, 15 deployments per day rate today at Veriff. Since deployments are also automated, so the moment you think it's ready and you merge to master, boom, deployment goes to live, you immediately get feedback, and since it really takes only a couple of minutes and seconds to replace those containers or images, then you also get very fast feedback as well. And the cool thing that since we were so virtualized, we realized that we have an opportunity to create as many test environments as possible. So rather than testing things in your own computer, you already deploy your branch into recently created test environment that has controlled conditions where you can execute those tests in CI flow. And since it's everything is virtualized, test environment creation is basically like a matter of seconds, and all the services you can define what you need to run your tests in that specific environment. And yeah, rollbacks also due to highly virtualized nature of our infra stack, rollbacks are really easy. You just deploy previous version, boom, from deploy manager, and you're done. So that's cool. So there is things to do still in Veriff, of course. So one of the things being the code coverage, where we would be also a little bit closer to Pipedrive situation, where for smaller changes you would not have to do manual testing. Those flows, those points are covered with automation suite. So measuring unit integration and also test coverage from UI test perspective is important, and it has to grow. We also now deployed automation, machine learning, automation black box testing. This is basically to validate, again, under controlled conditions. If we do any changes in our automation stack, we have a predefined data set that is flowing through the tests and then basically showing us, did we improve anything? And since we control the input data, we are able to compare the output data effectiveness of automation stack as well. Yes, you have a question?
Yes, please. Thank you. So how do you stand on code coverage? How trustworthy do you find these metrics? And if you do find it pretty much trustworthy, so what are the bad or good numbers?
Yeah, it's a little bit loaded question. So what we have done is that we actually have given team the authority and autonomy to choose the tooling and set the levels that they feel comfortable with. It's very, actually specific to technology that you're using. It also depends on the maturity of the service. So if you need to deploy something quickly, probably not going to delay because of the test coverage is low. But the team knowing that if they need to do an update after a couple of months or even a half year later, they need to know that, okay, if I have those tests, I am feeling much drier to do that change and use the same test that I created in the beginning as well. So some teams are at 80% unit test coverage, some have 10%. So of course, all the legacy stuff, all stuff that we know, we just don't touch that much anymore. So it's context related very heavily. So I finished with black box, so that's to test our machine learning stack. Then the other thing that we are currently developing is sort of an end-to-end smoke test suite that would run always for each component deployment. This would run. So we basically have a couple of flows there that we cover. So if you think about Veriff as such, the flow is that end user generates a session. We capture the picture of media and face and video. Then it goes through the approval engine. We approve it either automatically or manually. And then we send the webhook back to the customer saying that this is the data that we extracted and this is the verdict that we gave to that session. So we want to automate that flow and execute that test suite all per each component deployment. And no matter does it have any relation to the functionality or not, we just execute it blindly and make sure that happy flow always works. Of course, since now we have built up quite a big of machine learning capability in Veriff, I'm also dreaming about sort of automated, or how we can create automated tests using human input just, that we would basically have anybody writing tests and then boom, automation takes over after the human input has been given. So some kind of automatic generation of tests, and tooling is doing very big steps in that area. One of the things that we always struggle with is that we need data for testing. We need those sessions, but those sessions are very, let's say, they are very sensitive, so we can't have those personal information lying around in test infrastructure everywhere, you know. So we probably need to generate lots of test data in future for ourselves. Yes?
You use or will be using generative these adversarial networks for test data?
Yeah, it's a good question, good idea. We'll see, I can't answer that at the moment. This is just sort of one of the areas that we need to invest in terms of investigating how to do that. Because if we generate too simple data, then we render our sort of testing useless as well. So, I mean, users are very clever. So our test data generator needs to be as clever as they are. So these are the ideas for the future for Veriff. So thank you for listening, and I wasn't terribly over time, so maybe a couple of questions. Yes?
It's too early to clap. So, we do have a brother.
Brother?
Yes.
Two.
Okay, good. So you have a brother which really looks you alike. And for Pipedrive and for Skype, it doesn't matter. Because for them it's user, if he stole your credentials, who cares, right? But for Veriff, that's quite a big thing, because it's KYC, and if someone, your brother, takes your ID card, looks like an antique pattern, and take a loan, lease, apartment, drugs, girls, and go somewhere else, you'll be in trouble, and Veriff will be in trouble. So, from a quality assurance perspective, can it be somehow testable, and what kind of approach you're taking?
Yeah. So, first of all, the automation stack works only if it's pretty much sure. I mean, I think that they are very close to 100% when they actually make decision automatically, whatever check they are doing. Now, if the machines are not sure enough, then it goes to manual review, where people only look at the things that machine was not really conclusive about, and then they make decision.
What about twins?
So twins is a big problem. Our approach to that is twofold. First, twins is always problem anywhere you go. Yes? but there is other things as well, you know. There is a possibility to query lots of databases about people. And this is developing scene. We can query those and cross-reference the data as well. But if we have identical twin posing as his brother or sister, and we probably will not catch it. I mean, let's be clear. But none of the people in the bank will do that as well. So it's a problem that yet to be solved. There are solutions what goes to machine learning. Actually, there is a difference in twins what goes to emotional state transfer. That becomes already pretty complicated. But even twins change emotions differently. So the algorithms can detect that whether the person last time is now a little bit different. So there is hope, but this is a little bit on the lab side still.
So basically, you put them in front of a bot, and then put them on an emotional swing. So you piss them off, slick towards them, and see how they react, right?
Yeah. So by emotional state, I didn't mean those emotions that you have. It's not so blunt. It's very sort of microscopic changes. And I know Tartu people have been researching that a lot, actually. So, with the verification, it's important to realize that we are here to protect the customer from the sort of fraudulent behavior. We actually, I don't know whether you noticed, but last year we purchased a company called Browser ID. And they do lots of device and network fingerprinting. So there are a lot more fraudulent markers before we come to the face, let's say so, that we can detect. But I wouldn't encourage twins to do that, because by they're doing illegal act and they probably get in trouble at some point of time. So I don't know, any of you are twins? No? Do you have twin? Anybody?
I have.
You have a twin?
Yeah.
Are you using this opportunity often?
I can tell. I cannot tell.
Ah, you cannot tell. Okay.
Yes,
Yeah.
You
Yes.
don't respond for another person.
Yeah. So basically, my hunch is that twins sort of know what is okay and what is not, and yeah.
And it's also probably pretty easy to prove that you have a twin.
Yes. But I mean, if there would be a government registry that we could query that whether this person has a twin, boom, problem solved. But we don't have those. Yes.
I'm presuming that what you're doing at Veriff is the future of testing. But just to be precise or shed some light, what was Pipedrive lacking then? What were they lacking that doesn't fall under the future of testing?
I think not much actually. Pipedrive.
Because I'm thinking of the graph you showed with Skype way out there in the ethos. And,
actually, it's not so. Skype didn't really, I mean, the productivity in terms of testing, like how quickly we could push things live, Pipedrive was much better at it when Skype was. In terms of testing depth, yes, it was higher there because, I mean, we had the automation testing stack running, we had 2 companies testing the same release candidate,
also
and,
Pipedrive.
no, in Skype,
Okay.
etc. So Skype was significantly higher because lots of more manual testing was involved. Those 2 companies, by the way, found different bugs, which was also interesting. So testing was a much thorough effort there. Also, you have to realize that Skype is downloadable application, so you can't really call it back. But in Pipedrive, it's SaaS service. You can change the image right away and boom, it works again. So from that perspective, that depthness, that thoroughness is not even necessary. Otherwise, it becomes too expensive to run. Yes?
Well, I understood that when a person wants to use Veriff, then he or she has to make an image of this ID from both sides and
Yes.
then make a selfie. But how can you be sure that these pictures have been taken at this same day? For example, maybe I do have a selfie of, I don't know, my sister, and then I can make a picture of her ID and use that.
Yes, so it's actually pretty simple because the flow is live. The flow starts on the, let's say it starts, you'll read through, on the 3rd second you do a selfie. On the, I don't know, 10th second you show your document front. On the 20th second you show your document back and click, make pictures. The whole thing is videotaped.
Okay, it's videotaped.
Yes.
Right? Okay.
Yes. So
then it's not possible to
no.
People intervene this kind of requests and this kind of.
People actually don't read the fine print, and they are doing lots of nice exercises in front of the camera, okay, and they're moving the camera. People are very creative, so yeah. But the fact that the whole session is videotaped, that removes the possibility of fraudulent activities that are stupid ones. There are more more intelligent approaches as well, but even that, we can detect slideshows computer screens, etc. That's relatively easy to get from the computer vision analysis.
What else do your application do that user doesn't know about?
Actually, user knows everything about it, so they just have to take the time to read through the service agreement or terms and conditions. Yes. And actually, I think we even say on the UI that you are videoed. Yes.
All right, I think it's time for us to take a break. Get a beer, get a snack, have some nice conversation. Let's see in a bit.
I'm living a hollow life. I'm living a hollow life. What am I supposed to do? I'm lonely here without you. All these days are passing by, standing here while you're living your life. I'm broken here alone. Where did I go wrong? Living a hollow life. I'm living a hollow life. You always want what you can have, and what you have you can. But still, my heart, the moment I laid eyes on it. Well, how do you know how you will feel when everything changes? This fear, where will I go? Where will you be? How will I know the one for me? How do you know? 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 You always want what you can have, and what you have you can. But still, my heart, the moment I laid eyes on it. Well, how do you know how you will feel when everything changes? This fear, where will I go? Where will you be? How will I know
When you dream, do you see beautiful rays of light shimmering, guiding you through the night? I know it feels like the night's getting longer and light is harder to find. I promise I'll always be there, I'll remind you when you close your eyes. If they send for me tomorrow, even if I leave right now, you'll find comfort there in knowing whenever in doubt, you can find me when the lights turn out. When the lights turn out. Even now, laying down hundreds of miles away, I can see you and me like it was yesterday. I know it's not the same, but I'm still behind you every step of the way. Look in yourself and I'll be there, I can guide you. All the love is the same. If they send for me tomorrow, even if I leave right now, you'll find comfort there in knowing whenever in doubt, you can find me when the lights turn out. When the lights turn out, you can find me when the lights turn out. When the lights turn out, you can find me when the lights turn out. You just walk right out the door. Don't wanna do this anymore. Now I'm lost without you. You drive me crazy out my mind. How'd you do this every time? Now I'm lost without you. Used to be the one I talk to when I'm sad. Can't you see now tainted love is all we have? Our issues run so deep, now when I try to sleep I feel so bad. I should leave and by the time it's done I'll be you see, now tainted love is all we had. Our issues run so deep, now when I try to sleep, I feel so bad. I should leave, and by the time it's done, I'll be gone. Get you one more time. I really wanna cross the line. I do it all before I die. I wanna get it on tonight. I wanna get you one more time. I really wanna cross the line. I wanna get you one more time, one more time, one more time, one more time. I want it one more time. I really need to make it right. Energy I overdose, 'cause I'm ready to reload. I need it one more time, but baby then again twice. But I don't know if I'm ready to let go. I'm gonna have you one more time. I'm gonna hit it one more night with you, with you. I am committed 'cause I know it's you I want. Hope I never see you go home. I'll come along. I'm gonna have you one more time. I'm gonna have you one more night. I wanna get you one more time. I really wanna cross the line. I do it all before I die. I wanna get it on tonight. I wanna get you one more time. I really wanna cross the line. I wanna get you one more time, one more time, one more time, one more time. Ooh, this time I wanna take it slow. I don't need my phone. I know how to picture in my mind the nights with you. I'm ready to enjoy the ride. I don't wanna die, but I could die in your arms, 'cause I don't need to live forever. I don't need to live forever. 'Cause I don't. I wanna get you one more time. I really wanna cross the line. I do it all before I die. I wanna get it on tonight. I wanna get you one more time. I really wanna cross the line. I wanna get you one more time, one more time, one more time, one more time. And every way you keep me started off fine, now then left going deep, deep, baby. I'll be right back here to see you just one more time.
Writers write what they know. Liars write what they wanna show. Singers sing what they told.
Delicious.
In tongues, snake like tongue tied, you on the run. Tribal dancing, I don't know what you are, you are, you are, you are. Summer floating over my heart. We're both dancing over the dark side. I don't know who you are, you are, you are, you are. You got letters sprinkled all over your body. If I join up the dots, it makes me feel naughty. I feel like I shouldn't touch. You got a no touching sign. I feel like I shouldn't run. You're blocking the exit with your life.
Now that everyone's ready, so quiet, I didn't expect that that level of self-organization. Thank you so much, appreciate that. Revo is already ready to kick off, right? So before we proceed, I actually messed up a little bit last time. So I wonder if Tit is still around. He doesn't seem to be, but alright. Then it's just we normally have a little gift for presenters, little branded DEVCLUB socks that say "Hello World," and this pair goes for Tit. So yeah, cheers Tit. And then another little request: if you are having a drink, normally you know putting your bottle in a trash can is a good thing to do, but as now it all goes to the racket, like all this bottle chin sounds. So please don't do that. Just quietly put it on the table and then throw it away a bit later. Thank you so much. And yeah, now please welcome on stage everyone.
Hello. So my name is Rivo, and I'm going to talk about how we changed logging in Veriff, specifically how we started using structured logging, and then some takeaways and lessons we learned during that. But let's do a quick show of hands first. Who here is at least slightly familiar with what structured logging is or how it works? Just a few. Anyone using it in production? All right. Looks like I can teach something new to most of you. So, quick introduction about who I am. I joined Veriff about 1 year ago. I'm part of the automation team. And while most of the automation team has rather data science background, then I lean towards a more traditional software engineering, which means that I'm often working on platform level stuff. And that includes also this logging overhaul. Tit already did introduce our project, but a very quick refresher is that you follow some instructions, you take a selfie image, you take some images of the document you've got, then we might also ask for an image of you with your document, and then the verification process begins. And in case of automation, that means that we basically run a whole bunch of services that will take a look at those images and the verification session in general, and we try to figure out what's going on there. Now, I will be using this extremely simplified version of face detection service for the presentation. If you have problems reading this, then I will be using lots of code in this presentation, and there are some seats in front here. So feel free to move up. But basically, as you can see, we download an image from S3, we run it through some face recognition algorithm and get the results, and then save those through our internal API. If we try looking at what this service logs right now, then obviously nothing, because we haven't added any logging yet. So let's fix this and add a bit of logs that say that we are processing this upload with this ID. And now we can see something. I already mentioned that we've got different types of images, so let's include that information in the logs as well. And it might also make sense to log out how many faces we found on this image. So now we're already getting somewhere. And this is roughly how the automation services looked like about half a year ago. We had about 15 microservices doing various things like face detection, figuring out if the face on the document image and the selfie face are those of the same person. We would try to read out all the text from the document images, and we would then figure out which of those words that we read out is your first name. And this meant that they are all sort of collaborating or working on the same data, like the same verification or the same image. And that also meant that if something went wrong, then we didn't often know what service the problem originates from. Is it that we couldn't read out any text? Is it that we couldn't figure out which of those words is the first name? We had to figure that out. And that means that we had to do a lot of searching by upload IDs, for example. We use AWS CloudWatch for log storage, and CloudWatch lets you write those simple queries. So in this case, we're searching for log messages where the message itself contains the particular ID. And this kind of gives us what we want. But as you can see, it's a full text search that just uses substring matching. And this comes with its own problems. Let me go back. And you can see that we do find the processing upload message, but we don't find the message saying how many faces we found, because we didn't include the upload ID in that one. Also, if we tried searching for all the logs about face images, then we do find what we want, and then we also find something that we don't really want, because it also happened to include the same word. So going back to our code example, one way of fixing it would be just put quotation marks around all the dynamic values, like this, and then also include the upload ID in the second message. And that kind of does work. We can then search for a face with the quotation marks around it. But this comes with a lot of assumptions, and as you can already see, this is quite fragile, because the developers need to keep in mind that they need to add those quotes there, they need to use this particular type of quote, and also basically we're putting a lot of mental pressure on developers. And if something goes wrong, then at some point you're like, yeah, I'll just use regular expressions, and that's not the way you want to be going down. So I hope I convinced you by now that just logging out text or prose is not very good. It's easy to do. As humans, we're quite used to it. But it's difficult as soon as you start doing something on those logs with machines, like searching. And as mentioned, it comes at mental cost for developers. So let's look at one better way, which is structured logging. And the whole core idea of structured logging is that we log data instead of just text. And as you know, data is already machine readable, which gets us around quite a few of the problems we already saw. So let's once again go into code examples. And this is a traditional logging call where we just create a message and then embed some data within that message. With structured logging, instead of a single message, we would be dealing with an event describing what is happening, or like the type of the event that is happening, in this case process upload, and then we add some additional context to it to describe this event in more detail. In this case, we're including the uploads ID as well as the type. And then usually you end up outputting and storing those logs in some structured format, like in this case, the JSON. And also the logging library itself can add additional information like the timestamp in this case. Now, JSON is not the most human readable format, so for this presentation, I will be using this simple text-based format instead. But always keep in mind that the data we're dealing with is actually structured and not text behind the scenes. One important thing that structured logging allows you to do is separate the event from gathering the context. So in this case, you can see that we start by binding certain data, certain attributes to the logger itself, and then later we will log out the event, the same process upload, and that means that the data we bound to the logger earlier will be included in the log event the same way as earlier. So the output is the same, but the important pattern that this lets you do is basically gather the context iteratively over time as it becomes available. So we might start by binding just the upload ID, then as soon as we figure out what the type of the upload is, we bind that one as well, and so on and so forth, and then in the end log out the message itself. So let's go back to our code example, which looked like this with traditional logging, and convert it to structured logging and have a little walkthrough here. As I already explained, we first start by binding the upload ID to the logger, which means that now every single log message or event that we log out will be guaranteed to have this upload ID. So the developer will no longer need to ensure that this upload ID is included everywhere. It happens automatically. Yes?
This would work when you pass context through the execution chain within the same process. But what if your process is actually distributed and asynchronous? How would you pass context then all the way down where it's actually logged?
I guess that would mean that you would need to pass that same context to the other process that is doing the, well, processing and somehow coordinate. But yes, you're right that...
Then it becomes kind of not nice. If you imagine code doing this, then it's
I'm not sure how many cases there are where you have the exact same operation essentially being done in different processes.
I'll give you an example. A customer initiates deposit, then it gets redirected to the payment provider, and then it does something on a payment provider, and then you receive callback from the payment provider to a different process.
Okay, so in this case we're already talking about distributed tracing essentially, and I will shortly talk about that later.
All right, thank you.
Sure. So continuing with this example, we then log out two events, the process upload and the faces found. And you can also see that we can add additional context that is specific to those events. So for the process upload, we will include the uploads type, and for the faces found, we include the count. And then our CloudWatch query becomes really straightforward. We just say that we want to find all the entries where type equals face, and then that is exactly what we will get without any false positives. So now that you have hopefully some idea of what structured logging looks like, let's go a bit deeper and compare it to the more traditional approaches, and also look at the whys and assumptions between both of them. So with traditional logging, I suppose one of the assumptions is that you have just one service, or perhaps a small number of services. This means that if anything happens and you need to start investigating it, you already know where to look. And it also usually means that you have relatively small number of log events. So you can just go and look at those raw log events without any additional processing. And so the raw log entries in this case are consumed by humans by just looking at them with your eyeballs. And because we are quite used to consuming text, then we also try to make our log entries look like an average text, which means keeping the line length down to a reasonable level. And if it gets too long, we often split that log entry into multiple ones. Today, though, we are dealing often with slightly different systems, ones that are distributed and use, for example, microservice architecture, and you can have tens or hundreds or even thousands of different services which make up the system. And as I previously explained our automation use case, it means that any incident response is usually not limited to a single service, and it starts by you not knowing where the problem is. And because all of those services generate quite large amounts of log data, you will absolutely need to have some sort of searching or filtering. It also means that you might want to, instead of consuming the logs as text, do something more novel with them, like graphing them, for example. So you might want to count the number of log entries per minute. And if those log entries are about requests made to some API, then essentially you get a graph of the number of requests made over time, which can help you pinpoint where the problem lies. And this means that the raw log entries are not consumed by us anymore. Instead, they are rather first processed by some system, and then we sort of use the processed or derived results. And as a result, we can also include lots more context with each of those events. So let's get into a bit more detail on that one. As said, we basically have this mindset change where we go from text logs to events and contexts. Events being something that is going on, like internal API request made or some upload being processed. And then context is additional descriptive data that helps us figure out what exactly was happening. And I have an example about some random API request being made. And with traditional logging, we might want to log the path or URL of the request, the HTTP method, the response code, maybe also how long it took. And then that line is already quite long, so we probably wouldn't include much more. We could do the same with structured logging, but we can also add lots more detail here, like how big was the response that we received, or what were the upload and verification IDs that we were working with at that time. And we can go much further and also include some information about the environment and application, like is it production or staging environment, what is the exact version of the application, and what is the commit hash of the source code that the application or service was built from. And this might seem like perhaps a bit too much data, but one day when you will discover that this particular incident you're working with was caused by, for example, a particular version of a service making too many API requests, then this will be quite valuable. Going on, we have also created a sort of internal Python package, because Python is what we use in automation team mostly, that basically adds some helpers and other ideas to the more standard or straightforward structured logging. So let's walk through those. First of all, we have some helper functions that let you add timing information to the logs. For example, we had that face detection service example when we first downloaded the image, then ran the face detection algorithm, and then saved the result. And we could add timing information about all three of those events. We also use Sentry for error reporting. So we have a Sentry integration which also makes sure that all this additional context that we're gathering anyway makes it to Sentry. Then we have another type of context called global context, which goes back to the idea of wanting to add certain information to all log entries, like the upload ID in this case. In this case, it works because we're dealing with one single function or one single logger, but this might break down if we're using some external package that uses a different logger that does not have that information bound to it. Or we might use some package which does not use structured logging at all and uses Python's standard library logging. And we wanted both of those cases to be covered, so we wanted to always get that upload ID in this case. And then we added some additional integration to make that happen. We also make use of something called canonical context, which is essentially a summary of what is going on. And the idea is that we might have some data spread across different log events. In our example, we had the type being added to one log event and the number of faces found added to another. But if we now wanted to search for, let's say, face images where we didn't detect anything, then we would have to somehow make that happen across multiple log entries. And the solution here is to create this canonical or like summary log entry, which includes all the important context. And then we can very easily just query that in CloudWatch or similar service.
Is canonical created automatically, or you just once more you log everything?
In our system, you say that I want this binding to be canonical, basically. So it works on the developer level. The developer says that this is important data that should be included in canonical log.
ID manually.
But then you can also do the query, like saying type this thing or this thing, and then assemble it all together.
Yeah, but then you have to assemble it. And it's kind of an ergonomic feature, so it basically gets around the assembly. I wouldn't say it's premature, because it has given us quite useful use cases. For example, it gives us metrics for free. So we use New Relic for metrics, and the canonical logs will contain stuff like timings or number of API calls we make. And then without any extra effort, we can get some nice graphs like this in New Relic. So basically, we're shipping the same data to different systems. Another use case is that you might store the ordinary logs for, let's say, a week or a month. And then canonical logs are those more useful summaries, which you might retain for longer. So even though you'll be lacking some detail in the future, you'll still be able to go back and look at how your system has changed over the course of a year, for example. Yeah.
I wanted to share a bit of experience. How did we deal with this distributed with logging of distributed events? So what we found out useful for us is passing over the kind of event UID. So the first time a piece of event or transaction gets logged, so it generates the UID, and then it passes it along to the next service as a token to context. So it doesn't have to pass the entire context, and then even though you don't have like one log entry per event, you have you can query one single transaction from the beginning to an end across the entire chain, like with this token.
Yeah, this would definitely be the case across services. So what I'm showing here is basically limited to a single service doing a single operation, like process one upload or respond to a single API request. But yes, if this service would make a request to another service, then you would want to include something like trace ID so that you can sort of tie together those requests later.
It's and correlation ID.
Different systems have different names for that. But yeah, distributed tracing basically is what you're describing here. To give you a real-world example, this is log from one of our services. And as you can see, it's kind of a wall of text. But you might also notice that there are some stuff that we already covered here, like the canonical entry, some IDs, the duration, and various other information that might be useful. And this also shows that it's not really readily human consumable. Like, you can find information in it if you want, if you really need it to, but you would rather use some other system to process it first. So moving on to the lessons learned part, the context here is that I think the first service using structured logging went to production in automation team roughly 3 months ago. And the automation team itself has now converted approximately half of our stuff to structured logging, with the rest of the company following, but we're still in rather early stages. So first of all, the data in the logs is much more useful than just logging text, basically. We already can filter it, use it in filters, use it in search, get some good stuff out of it. As I showed, we can also send the same data to multiple systems, like in our case, New Relic for metrics, and sort of get that for free. And most importantly, there are lots of opportunities when we find the right tooling to use that data with, which brings me to our pain point, basically, which is that tooling is slightly problematic. Searching is really good, but if you want to consume and read the logs, then that's slightly less good, because most of the tools that we use, they are made for textual logs, and they are made for events that don't contain that much data. And yes?
In particular, we are using ElkStack for gathering such logs and metrics. And then in Kibana, you get a representation with a table that, like you select fields or attributes that you're particularly interested in. And then reading a table is quite natural to a human being.
Yeah, but if that table has lots of columns, then that's still something you need to deal with, or select those attributes then.
Normally you care about a few columns and then you select these ones.
Yeah, that's definitely true. And so, looking into the future, better tooling is one of the things we're looking at now. Be it ElkStack, be it something else. We're basically exploring some opportunities there. As we already discussed, we're also looking into distributed tracing. So currently we kind of can correlate what's going on using those upload IDs and verification IDs, but using the proper trace IDs or correlation IDs would make the whole process a bit more straightforward. And depending on the tooling, you would then also get some native view of the call graph, basically, going on between services. And finally, just adapt all of our services to structured logging so that we can get a single unified view of that within the entire company. So I also included a summary slide as is required. So basically, the structured logging is about logging data instead of text with some bits of data embedded into it. You need to sort of change your mindset then to focus on the events and the context that describes those events. The primary consumer now shifts from the human to the machine, and that also means that you can include a lot more context and basically unlock new opportunities depending on the tooling. I also included some links in the slides that you can check out later. And if you have any questions, then I'd be happy to answer them. Thank you.
Will you be upgrading your old logs to the machine-readable format?
Yes. You mean the logs which are already stored?
Yeah.
No.
What will happen to old logs?
The old logs, we will just hope that we won't need them again.
They will remain old.
Yep.
How much effort do you put into complying with GDPR, the data privacy regulation, when it comes to logging?
So when it comes to logging, the basic idea is that you don't log personally identifiable information, which is kind of a bad idea anyway. And once you do that, there shouldn't be any further compliance issues.
Well, Yeah, the problem is that this definition is quite broad. For example, the IP address is specifically mentioned in the declaration, but also if, for example, location data plus timestamp together uniquely identifies a person, that becomes personal data.
I would include location and IP address in this PII definition. So basically, whatever data the user sends to us, we don't want to log those. We want to log, let's say, decisions that we make. The IDs, we can use those IDs later to look up the specific data that came from the user, but you shouldn't add them to the logs.
So, answering to this question, you can kind of, forward it to New Relic or AppSign or whatever you are using. They do that for you, and then you don't have to comply, and then you kind of get away with it.
But then how do you comply with the data deletion?
You don't. I mean, it's not yours; it's theirs.
So I have a question. So you have lots of microservices, right? And then it means like there are different teams doing these microservices. Then you have this common approach of logging. Do you have like common vocabulary or something like that? Like if you talk about photo, then we name it photo, not a picture. If you talk about this, so everyone, like when you search logs, you understand what you have to type in, so you find the relevant information.
We mostly have a common vocabulary, and we're working on like unifying the parts which are not there yet.
So then in this case, when you come to another team and say, okay, now you use these words, so you have to then still cope with this difficult situation.
I think this has been more of a problem when we look at stuff like user interfaces, not so much when we look at databases or logs in this case.
One more question related to PII. I understand the problem. The PII is actually logged in some kind of databases related to particular customers. So if you are finding from logs something, you can somehow get possibility to look back at what was the location that we couldn't match to something or like that.
I don't exactly understand what you mean.
Let's say there is a problem of not detecting three faces from an image which has to have three faces. We probably need to go somewhere back and look at the image.
Yeah, we can definitely do that.
So the private information is stored somewhere but outside of the log files, so log files are safe and the data is somewhere.
Yeah, the log files are safe in that they don't contain PII, and then we have like separate domains, let's say, like database, which does contain personal information. And then we can correlate those with IDs.
Thank you, first of all. What those log processing tools which you're using cannot do for you, but you would expect them to do? How smart they are?
So I think the biggest problem has been that they are not that good in showing a subset of log entries. So, for example, we might want to look at them as table, which contains only a couple of columns with information that we find relevant at this moment. Also, what we can't do is like advanced graphing possibilities where we sort of use graphs and drill into the data, adding more and more filters over time, which some tools are capable of doing.
Additional thing. Where is the line when only analysts can process those things and all these tools are not in the game anymore?
I think that personally I feel logging is more related to operational data. So you don't usually at least use them for analytics. You use them to look at specific cases of what has been going on, or perhaps generate metrics, at which point it starts resembling the analytical work more. I hope that answers your question. Anything else? No?
Yes, that would be it.
All right, thank you.
Well, thank you so much. This is the hope to see you again at DEVCLUB stage at some point. And thank you. So now we have a short break, like 15 minutes, I guess, and then we'll proceed with the last talk by Martin. So stay tuned. Thank you.
You hurt me, you did, several times. It hurts to admit that we're no different. I find it hard to commit, but you don't even try. Still I'm better with than without you. Oh, I'm on it, I want it, but why do you seem to call it your eyes? I can't tell if you're here or you're out there. Do you wanna be out there? You don't need to be Prince Charming to me. I just need this to be real. I don't need no fairy tale. You don't need a kill, pregnant for me. Ooh, I don't need no fairy tale. We run and go still every time. Whatever it is, I keep on trying. 'Cause it ain't hard to forgive when you know what it's like. That's why I'm better with than without you. Oh, I'm on it, I want it, but why do you seem to call it your eyes? I can't tell if you're here or you're out there. Do you wanna be out there? You don't need to be Prince Charming to me. I just need this to be real. I don't need no fairy tale. You don't need a killer, pregnant for me. Ooh, I don't need no fairy tale. You don't need to be Prince Charming to me.
Wishing that I could run away with you. Imprisoned by fear, just pull me away, pull me away. Secret fantasies of me. Will they ever see the light of day, light of day? I don't know where you are, but I will find you. I will find you. So if you're out there, just run until the edge and fall into me and see where this could end. Make our own life and leave this world behind. Can you hear me? Do you feel me? Wishing that I could run away with you. Imprisoned by fear, just pull me away, pull me away. Secret fantasies of me. Will they ever see the light of day, light of day? I live inside my own world of make-believe. Kids screaming in their cradles, profanities. I see the world through ice covered in ink and bleach. Cross out the ones who heard my cries and watched me weep. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Take my eyes open to force reality. Why can't you just let me eat my weight in glee? I live inside my own world of make-believe. Kids screaming in their cradles, profanities. Some days I feel skinnier than all the other days. Sometimes I feel
Ladies and gentlemen, let's kick off in a couple of minutes, so please be ready. Thank you. For tonight, we've been two very good and technical topics, very detailed testing and logging. Now it's time to take it a bit easier and get into a bit of a softer topic. Yeah, I think a bit of taking a good care of yourself and such. So for this, I would like to invite on stage Martin. He have already been to DEVCLUB with another great talk on brewing beers. Yeah, exactly. So now it's of course not less important topic of a good quality sleep. I mean, man's busy in his life, right? And so please welcome Martin on stage.
Thank you. So like Stanislav saying, everybody needs to take care of themselves, and it's not that much directly development related, but all developers at least should know why we sleep and how to do it better. I hope I can explain it somewhat better. So this talk is mostly based on Matthew Walker's same name book. This is where it all started from me, and I guess you read the excerpt, the summary. So if you are short on time, if you want to go to sleep, read through this. You know what will get better, and go to sleep. I don't mind, and that's actually really good for you. But jumping into the sleep topic, then first thing I want to tell about is the circadian rhythm. So all the plants, all the humans have a circadian rhythm. It was first discovered or noted, I think it was in 1500s, when first scientists started noting that some plants open their blossoms during the daytime and close them in the evening, and then took these plants into complete darkness, and later in the darkness understood that it's not the sun that is affecting those plants, but they still open their blossoms and close the blossoms in a 24-hour cadence. And in, I think the first human experiments were done in 1700s, 1800s, where two scientists wanted to try out how long is a human natural circadian rhythm. And they went into a really deep cave in somewhere in Scandinavia, I think it was Norway, for 65 days. And the experiment concluded that human circadian rhythm is around 24 hours and 15 minutes, plus minus 10 minutes for those two scientists. It later came out that as they did actually light some lights to simulate the day, then this messed up the experiment, and the human circadian rhythm due to evolution is actually quite close to actual full cycle of the day. It is a little bit longer on average, but mostly it's the same. And even if your circadian rhythm is a little bit off, then what triggers the sync for your circadian rhythm is the daylight, the sun. It is also the noise. If you wake up in the morning hearing, I don't know, airplanes, trams, whatnot. And it can also be reset with eating, for example, just getting some food into your body. But circadian rhythm is not the only sleep trigger. Melatonin production is one of the second bigger sleep triggers. In the evening, when it gets dark, your body starts secreting melatonin into your system, and melatonin is basically, it's called the darkness hormone. So in case it's dark around you, melatonin is secreted into your body, and your body starts thinking that it's time to sleep. So in case you take melatonin supplements, it's not a sleeping pill, it just is telling your body that it's dark, it's time to go to sleep. And another thing that's actually happening is that during so this process C here is the circadian rhythm, and the process S is the sleep drive. And substance called adenosine, it's called sleep pressure, in other words, is building up all during the daytime, and when you get to sleep this drops really rapidly, and when you wake up in the morning it starts building up again. And as you can see, it's usually in the same cycle with your circadian rhythm. So in the nighttime it helps you sleep, in the daytime it is really small, the sleep pressure, so it's yeah.
So does it drop every time you fall asleep?
It drops while sleeping, yes.
So it's basically like also the rationale behind power nap, so like you nap for a bit and it helps you to drop the sleep pressure.
Yes, exactly. The sleep pressure drops when you sleep, and then after a power nap then you feel more refreshed. So like you can see on the picture, the greatest urge to sleep comes when the sleep pressure is the highest and the circadian rhythm or the wake drive is the lowest, so you feel the less energized. And when this gap is the biggest, then during the evening time usually, this is when you want to fall asleep. But what happens if you skip a night of sleep? Then the sleep pressure keeps building up, but the circadian rhythm starts in the morning again to energize you. So that's why you feel actually more energized in the morning, even though you have not slept. So after sleeping, it would drop, but if you don't sleep, then the sleep pressure keeps building up slowly, but the circadian rhythm boosts you so much that your energized level is way bigger than the night before or the next night when it's going to be overpowered or overpowering you. So that's why you can have this, so to say, second wind in the next morning. Another great thing that has been invented is the caffeine. But what do you think caffeine does to your body? Any suggestions? Yes? Yes?
Borrows you energy?
Borrows energy, gives energy.
Creates stress.
Creates stress, yeah, sure. These are all good answers, but everything except the great stress might be wrong. The stress thing, I don't know about that much, but what caffeine is actually doing is it's blocking the adenosine receptors, so you don't feel the sleep pressure. So if you drink a lot of caffeine, your adenosine receptors are blocked, you don't feel the sleep pressure building up on you. And when the caffeine actually leaves your body, there's going to be a big hit. All the blocked off adenosine is going to actually affect you and you're going to have a crash. And regarding caffeine, then especially for the elderly, like myself and some other people here, most of you are young, but for older people, the caffeine processing is getting slower and slower. Your metabolism doesn't consume the caffeine as fast as when you were young. And just to let you know that the regular 30-year-old person, like the caffeine half-life for a 30-year-old person is around 5 to 7 hours. And also beware of the decaf coffees, because they actually consist still of like 15 to 30% of the caffeinated coffee. So not all the caffeine has been taken away from there. Oh yeah, I actually have a slide on the age. So anyhow, it's getting bigger and bigger if you get older. And I guess I'm just missing the really old part on this one.
Is it old? So it's like at first it's shrink and then it's increasing again.
Yeah. First it's really big, and after some point it's starting increasing again. So I first built the slides based on the first book, but after that I read a few more, and so it's not only what's written. So let's talk about sleep phases. I guess everybody knows about REM, rapid eye movement. This is the dreaming phase, and the non-rapid eye movements have been categorized into 3 different stages. So the first one is transition into sleep, then comes light sleep, and then comes deep sleep. So just average on how much time is spent on average for a human in different phases, but I guess this one is more relevant. So from your sleep time, how much of what stage of sleep should you get? And I'm going to dive into the stages a little bit more detail. So stage 1 is so light sleep. It's the transition into light sleep when you don't know that you are asleep. If somebody is saying, like especially your significant other, hey, you're snoring, and you're like, what? I didn't even go to sleep yet. Like, what the hell is this? This is the first stage. You actually are already sleeping, but your brain is still so awake that you don't understand yourself that you're sleeping. This usually lasts for just a really small time, and this is just to transition into the actual stage 2. That is the main light sleep phase. So light sleep phase is, this stage 2 is required to transition between the deep sleep, that is stage 3, and the REM sleep. So you can never go directly to deep sleep or REM sleep, but you have to be in stage 2 to actually get there. There's a lot of technical jargon, you can read through it later, but this is basically the main body of light sleep. This is the red part here. So this is what humans spend the most time of their sleep in. And basically synaptic pruning, memory consolidation, so these are the main things that happen here. Then comes deep sleep, stage 3. Actually, there used to be stage 4 as well, but stage 3 and stage 4 were so similar that nowadays the newer literature has it all merged up, but one of my next pictures is going to have them separately. But nevertheless, deep sleep is the most restorative sleep cycle ever. This is where your body rejuvenates, where your muscles get new energy, where your muscle fibers are rebuilt if you have done a lot of training. So this is basically for physical restoration. And then comes REM sleep, also known as rapid eye movement. This is when we dream. What happens during dreaming is that basically your brain is cut off from your spinal cord at your neck level, so that you are paralyzed, that you don't act out your dreams. And if this function is not working correctly, then you might be sleepwalking or turning yourself out of the bed. And the fun fact about that is that when women are pregnant and you touch their belly about the kid is kicking, the kid is actually dreaming and acting up his dreams, usually his or her dreams. And as rapid eye movement is really needed for the neurological build-up, and the babies at the final stages in the womb need to build a lot of brain matter, then they are sleeping like 80–90% of the time, and that's why they are kicking all the time, because the function that cuts off your physical movement has not developed yet. This develops around 6 months to a year, so that's why small babies in the womb and out of the womb move a lot when they sleep, and grown-ups don't. What also happens during REM is your brain gets flushed. So the brain matter actually shrinks in size, and the brain fluids wash around during the REM phase, so that all the dead proteins that have been left out after the processing or some of the cells die, then these are washed away, and this is where so basically the REM stage is mostly meant for the mind to be restored. As deep sleep was for the body to be restored, then REM is for the mind to be restored. Yes?
What is this light and REM regular sleep that occupies most of the time? What is that for?
So this is basically just a transition from one to the other, and then what's said that the memory consolidations are happening during that time. So basically, if you know that, I don't know, let's take an example that beer should be cold, and then if you are warm, then you should have a cold drink, then your brain will put together that if I have a cold drink when I'm warm, then it will basically making the associations and these kind of things.
Kind of summarizing the day.
So basically, yes, making new connections from the facts that you have learned. So in engineering talk, basically the ETL, the transformation of the production data into the data warehouse and making new connections and whatever.
Data analytics.
Yeah. Also, just a fun other fact was that what happens during REM is that emotional sharp edges get removed from your memories. If you have had really stressful memories, I don't know, a car ran over you, I don't know, maybe that's another good example, but later you will remember that the car ran over you, but you don't remember the pain associated with that much. So that also happens during REM, that you will that the emotions will be removed, or at least the sharp edges from the memories will be removed. And to talk about cycles, the first thing that the human body does is that first you fall into the light sleep, and soon after you will fall into the so the transitions into light sleep, you will be in the light sleep, and ideally you will go into the deep sleep. So on this picture, it's from an old book, so there is the 3 and 4, but they're both basically the same deep sleep. The first thing that the body wants is physical restoration. So next morning, if you wake up too early, or if the tiger comes into your campsite during the night, you need to be physically restored to be able to run away. And the more later you get in the sleeping time, the less deep sleep you will get, and the more REM stages you will start getting. And the most REM sleep you will get is usually late in the morning. So if your nights are short, if you cut them short by going to bed too late or waking up too early, your mind restoration, that is really important for people working with their head, will be disturbed. Yes, Steinstoff?
Question regarding the duration of the cycle. So here we can see that it's like approximately like an hour and a half, an hour and 40 minutes.
It's around 1 hour and 30 minutes usually.
Is it also for adults and children and everyone? Is plus minus, or it's very individual and varies greatly?
I am sure that it is in all of the literature. It's described that it is definitely a 90-minute cycle for the adults. I am not sure about the children, as they are usually way faster with all of the processes, then it might be quicker, but I don't know for sure.
What I've noticed with my 2-year-old, and then it's like around half an hour, then it kind of, you know, in a very light phase, and then this is like when you disturb her a bit, then she woke up, and then when you don't, then she kind of falls in another half-hour phase.
I actually, now that you say, I have a good story for that as well. So I used to have 2 daughters, and both of them slept not that well. With the first one, it was okay. With the first one, when she was really young, I needed to be walking with the caddy all the time. Well, winter, summer, whatever, you put her in the caddy, you walk around in the park, wherever, and she doesn't wake up until I keep walking. The minute I stop, she wakes up. With the second one, it was a little bit easier. When she falls asleep, you have 25 minutes to sit and read, then you need to stand up, and at the 30-minute mark, you need to be walking. The next one, it's already like plus minus 5 minutes, so you can have only 20 minutes to read, and then you need to be walking. And so you never know like how big the cycle was, but so I guess from that the cycle for the really young ones, like a year and or something like that, could be around 30 minutes. So it was definitely that. If I wasn't walking at the 30-minute mark, then she would wake up and never go back to sleep. So just another quick thing about sleep efficiency, that this is dropping really fast if you are getting older, especially for the males. And there has been going out the legend that older people need to sleep less. No, they actually don't. And that just their sleep efficiency is so bad, and they keep waking up. And nowadays, a lot of neuroscientists are saying that this might be actually one of the causes for Alzheimer's and all of the rest of the mind diseases that affect you at your older ages, is that you just cannot sleep that much. So if you take care of your sleep and sleep properly, these diseases will not come.
Actually, I noticed that the difference is only 4%.
Yeah. So it's not. The scale looks really bad. The scale looks really bad, but the efficiency. This is an average efficiency, so this is not that bad, but it does drop drastically. If we have time, I can show you later my statistics, and I never get 90% of sleep or the efficiency, and I'm not even in the last 3 segments yet. Just some fun facts about people who have slept less than 8 hours and more than 8 hours. So what were the differences? But this was just taken from the book, and just sport facts.
By the way, speaking of, there was an NBA player's stats.
Yeah.
I somewhere read about LeBron James sleeping like 11 or 12 hours a day, and then you know, just to be able to keep up with all that pressure that is applied to him with exercises and that.
Yeah, and I guess he trains like crazy also.
Yeah, exactly.
I've heard stories that he does like hours and hours full of like just trying the same shot over and over and over again, and getting really high results on that. So benefits, it makes you live longer. Your physical restoration, your cells being able to recharge better. So the memory and creativity comes from those cycles during REM, that your mind gets renewed. The attractiveness, slimmerness, and the food carvings is actually also a nice thing. There are 2 hormones in human body called leptin and ghrelin. One of them controls your hunger, and the other controls how fulfilled you are if you eat something. And of course, if you don't sleep, you feel a lot of more hungry, and you feel less fulfilled. So whenever you lose sleep during night, the next day you want to make it up because you stayed up and wasted more energy just by eating more. But it's not actually making up the lost energy, but it's just that your hormones are telling you you need to eat more. You are not fulfilled even after the second pizza. You need to have a third one, and then that's where the food carvings come from. Regarding cancer and dementia, is that during sleep, telomeres that are at the end of your DNA, the small parts that keep the DNA intact, actually, if you don't sleep, they shorten quite rapidly. And if you don't sleep for a long time, then these telomeres at the end of the DNA helixes can wear out. And then if the DNA helix breaks in any of the cells, then the cancerous mutations start to happen in your cells, and that's where the bigger diseases come from. Also, your immune system is boosted during your sleep. So in that sense, it wards off the colds. And of course, physical restoration also covers the heart disease and the strokes option. And you feel happy, less depressed, and less anxious if you have been well rested. So in another way, I briefly talked about those things regarding poor fertility, is that testosterone and sperm quality and egg quality have been significantly reduced if there have been longer periods of less sleep. And I think I covered mostly the other things. So why don't we sleep? The electric lights, especially the LEDs. So in the evening, if you look at LEDs, especially if you look at blue light, then your body thinks that the sun is still shining. It's too early to start producing melatonin, and your sleep drive is not that big because your body doesn't think it's dark outside. So even if you have a green LED light or like whatever LED light somewhere in your bedroom, just put the black tape on it. You don't need it. You don't need to see that TV is on standby. Or better yet, take the TV away from the bedroom anyhow. To regulate the room temperature where you sleep, human body temperature needs to drop around 1 degree Celsius to actually fall asleep. So cool room temperature, ideally around 16 to 18 degrees would be perfect, and just a warm blanket and socks. If you keep your feet warm, then your body will start reducing heat quicker. I talked about caffeine with alcohol. Some people think that if you have a lot of alcohol, it will help you sleep. I used to think that as well. It's just a sedative. It will knock you out. You will not have the regular sleep cycles. You will not get the restoration benefits, neither for the body, neither for the mind.
But one beer or one wine glass itself?
Basically, one beer or one glass, one small unit of alcohol before you fall asleep. You might feel a little bit more drowsy, and just taking the time after this one unit of alcohol, whatever way you want to have it, then you go brush your teeth, then you maybe talk to somebody, then like maybe read a paragraph from the book, and before you fall asleep, it's usually gone. And it doesn't affect you that much, and even if it's still in your body somewhat during the time you fall asleep, it's not that bad. But what's really bad about alcohol is that during when alcohol breaks down in your body, it produces these aldehydes, and the aldehydes are the worst nemesis, or how you say, against REM sleep. And if you are really drunk going to bed, it's taking the whole night for the body to break down the alcohol. In the morning you have these aldehydes in your bloodstream, and the morning is exactly the same time when you need to have these REM sleep cycles, and aldehydes are the biggest basically they're the biggest blockers for the REM sleep, so you don't get any of the REM sleep. Yes?
Another thing is that while you're asleep drunk, then your body or your liver is busy breaking down alcohol poisons, and then at that time it doesn't break down proteins and other good nutrients. So then your body doesn't repair as well. So
yeah, your body is not in the resting mode. It's the same thing. Somewhere in the next slides there is going to be that don't eat a heavy meal before going to bed. It's the same thing. Your body is still, the metabolism is high because you need to be breaking down still some of the things, and your body cannot rest.
So it's better to do heavy drinking in the morning?
Yes. If you need to do heavy drinking, do it in the morning. That's actually at the end I have a slide of links, and one of the links is to Matthew Walker's, the same author of the book, basically, is to his talk, and there's also this same approach that if you need to do some drinking, do it in the morning. It's best for your body.
Before driving to work.
And the legacy of punching cards is basically it's not that common in the engineering area, but a lot of people need to be at work sharply at 8 or sharply at 9, or you need to take your kids to your kindergarten at 8:30 latest. So that means that you need to wake up for an alarm clock, and where it all came from is that during the industrialization era, when the factory started working, then they needed all their employees to come to work at the same time, because they needed to put the lines to move, and like everybody needed to be there at the same time. So basically, what I'm getting is that if you wake up on an alarm clock, your body will be in the, so to say, flight or flight regime. You will be really stressed when you wake up, and this is a lot of strain to your cardiovascular and nervous systems. And You know what happens if you snooze the alarm? You do that to yourself again and again. So you stress out your body in the morning that much that, so if you can and you are able to, try to set your sleeping cycle so that you can wake up naturally. Or nowadays there are those cool lights that start slowly lighting up like the sun. We have a question there.
I have a question. So if instead of an alarm clock, for example, somebody else wakes you up, like your girlfriend or something, is it better then? Because it's maybe a bit more positive than an alarm clock? Or
Yeah, so the question, just in case somebody didn't hear, was whether if your significant other wakes you up, is that better? Of course that is better if you get waken up by kisses. If you get waken up by the pillow, like, hey dude, you need to be moving, then maybe it's not that great and it's stimulating the same alarm clock. But
maybe it's like as the same alarm clock is like every day, then your brain already like every time you hear it, you already have this negative thought with it anyway. Or
it still stresses your body because evolutionarily the alarm clock means that there is a tiger in the bushes and you need to start running, like wake up and start running. There is another question.
What about these sleep cycle driven alarm clocks and apps and devices? How much better is it to wake up into your, like at the end of your sleep cycle as opposed to in the middle of your sleep cycle? Does it actually help?
Yes, it helps a lot if you wake up during your light sleep. If you are waking up during your REM sleep or deep sleep, then this is where the strain is the most biggest. Because light sleep is what it says, light sleep. And you get waken up from there way quicker and with less
Even though you actually undertake this 15 extra minutes of sleep, it's still better.
Yeah. So I've tried some of the apps, but for me they didn't work out that well. So for my personal experience, I cannot tell whether these work well or not. Definitely do try them if you want to. I just wake up without an alarm clock.
I tried them, I couldn't tell still.
How hard to do it? But do you go early to bed or?
No, I just don't sleep well. That's why I'm covering the topic. I live in a place where I can hear morning airplanes really well. So at 6:15, the first ones come. If I can sleep through them, then 6:50 is the next peak cycle when at least 3 or 4 of them come. And I also do live next to the tram park, so in the morning they have those curvy roads where they all need to go out, and some of them also have those checklists like the planes that, yes, I need to test the brakes, I need to put on the lights, and I need to use the buzzer. So in that sense, I have natural alarm clocks around me quite a lot, but occasionally I do get to ignore all of those and wake up at 8.
What about earplugs?
Yes, I've tried earplugs, but there is a personal issue that if I use earplugs for one night, then I need to go to the doctor to get the ears flushed. I get too much wax. So if they work for you, do use them. But I just have a lot of things at the same time that are messing up my sleep. So that's why I need to read the books and try to follow my own advice. Just a few things that to bring out regarding sleep loss. For example, if you are losing weight when you are sleep deprived, then 70% usually of your weight that you lose comes from lean muscle mass. But if you have properly slept, more than 50% of the weight comes from fat that you can lose. So if you are sleep deprived and are trying to lose weight, then it's actually not beneficial for you and you are actually losing the good parts. We briefly talked about reproductive systems. So your testosterone levels are way lower. The fertile sperm counts have been said to be 29% of what they could be. And testosterone is not only for males, but actually it's also important for females. In regards of testosterone is one of the things that helps to keep your bone density, plays a vital role in muscle gain and keeps your brain sharp. So it's not about only the sexual urges. Regarding the cholesterol regulation, then your HDL is way less controlled if you are sleep deprived, and it builds up. And the other thing what might happen if you are sleep deprived is that you get the microsleeps. Those are like 1 to 2 second long sleeps. But imagine if you are going 100 kilometers an hour on Tallinn-Tartu road and you fall asleep for 2 seconds. Like if you have a drunk driver coming against you, at least there is some control. But if you have somebody sleeping for those 2 seconds, then it can be disastrous. So
do they happen uncontrolled, so you can't?
Yeah, if you are really sleep deprived,
randomly.
Exactly, those come really uncontrolled. If you are really sleep deprived, you think that yes, I can pull it through, but you just fall asleep and you might not wake up in like a tenth of a second, but after 2 seconds, and then it's already too late. So for these cases, it's definitely suggested that you should pull over and try to sleep at least like 20 to 30 minutes and carry on then, and not continue if you already see that you are dozing off or falling off. So briefly also about insomnia. Basically, insomniacs have lower quality of sleep, and it's mostly due to them having higher body temperatures and higher levels of cortisol. And their body is constantly keeping this fight or flight mode on, and they are not able to relax enough into going to sleep properly. And sleeping pills are not recommended actually, because sleeping pills also work like alcohol. They work like sedatives. You don't need to take pictures, I will send it out later. But just a saying. And because sleeping pills, or most of them at least, work as sedatives, they also knock you out. You won't get through the same cycles, same as with a lot of drinking. You get also rebound insomnia. When you quit the sleeping pills, then you cannot fall asleep again because your body is just so messed up regarding those. Being on the pills, and that's why they are also called memory erasers, because you don't get this ETL process. You don't get the short-term memories moved into the long-term storage and the connections made in your head. And the worst thing, if you take sleeping pills per year, your baseline of taking no sleeping pills compared to taking even 18 pills per year, we're not talking about days or months, but per year, is that 3.5 times higher risk of death, just because of they do mess up your body chemistry so bad.
How do you die? You just don't wake up, or...
That's a good question.
That's usually how people die.
No. I mean, like, you die asleep. Like, you just fall asleep and then you die there, or like...
I will take that question offline and look at what was the exact reason. I'm not exactly sure whether it was described or not, but I don't know by heart.
All right.
This is just a funny number from 2017, how much sleeping pills were just in the United States in 1 year. How big of a business it is. So big pharma is always pushing for them, but this is not so good. So also about what could be done in the future. So for example, that you can have a sleep tracker on your wrist, hand, head implanted that will control the room temperature. If you feel that you are getting, if you are getting too warm during night, it will lower the room temperature. If you get too cold, it will put it slightly higher, so that you will always have the ideal room temperature at your bedroom, for example. It's also been talked that, for example, for office buildings, that if it's 8:30 in the evening, all the lights turn into the red zone. They will eliminate all the blue light, so that the action, and this can also be done for the computer screens, of course, right now already with different apps. But if you're talking about the lights at the ceilings, then this could be one of the things to do just in your home, in the office. Quantifying, this is already here, at least for me. And it works not only for sleep. If you want to be better at something, quantify it. Start measuring, put down numbers, and that's all you need to do usually. At some point then you will start understanding, oh, I did that yesterday and now my score is a little bit worse, and maybe I should like not do that anymore. And also, maybe we could do immunizations based on sleeping quantifications, because if you have been not sleeping well, your body will not take into I mean, if you get yourself vaccinated and you haven't been sleeping properly, the antibodies will not be formed quite often. So it's a waste of vaccines. Why don't we have sleeping classes for kids? I mean,
they haven't. Children got just go and sleep.
Children are the last ones who have trouble.
No, I mean in school, like the same goes for why can't we teach our children how to do taxes? Why do they need to learn that? I don't know, like amoeba is just some single cell organism that multiplies by, or sorry, reproduces by multiplying. Why don't they learn sleep? Why don't they learn taxes? So
it's too early. By the time it becomes relevant, they forget about it.
I don't know. Will they?
He still remembers the amoeba.
I do remember the amoeba still. Yeah.
But you don't take them seriously, right?
So anyhow, what to do better? If there is one thing that you want to take away from this talk, fix your sleep schedule. Try to do it constantly around the same time. This will mostly cure a lot of the issues. Exercising too late in the day, your body temperature will stay too high. You will not be able to cool down. That's why you will not be able to fall asleep. Caffeine and nicotine, basically, they just get you going. Nicotine is a stimulant. Caffeine blocks the sleep pressure. Alcoholic drinks, also touched upon a little bit already. Same for the meals and big beverages. Your digestive system is so active, and your body will not be able to cool down and slow down. And of course, medicines that disrupt your sleep is self-explanatory. Napping after 3 p.m. If you do that, you will not fall asleep so easily during the actual time when you need to sleep. So if you need to nap, if you are sleep deprived, try to do it earlier. So also, before going to bed, put away your screens, just read something on the paper, talk to your significant other, meditate. Regarding a hot bath, then this is good for lowering your body temperature. If you go to the bed with a little bit higher body temperature, it will fall more easy, and you will be able to get this 1 degree decrease. Gadget-free, everybody understands. Dark and cool, this is the same for the melatonin production, and cool means that it will help your body temperature lower again. And right sunlight exposure means that if you don't get the sunlight exposure early in the morning, then you don't reset your circadian rhythm. Your body will not know exactly when to start producing the melatonin if you get it messed up, if you're constantly in the artificial lights. And the last one is just if you wake up and you see that you cannot really sleep, and don't stay in the bed. Otherwise you will just not feel comfortable falling asleep there, because you will just feel that, oh, I can't get sleep. Just go to the kitchen, walk around, read a book if you really cannot fall asleep, and try again a little bit later, so that you don't have such big expectations from it, or it might happen more easily. So, bears down, to bed. I don't know how I'm with time. I actually have.
Get some time for questions. I mean,
it's not time for questions yet. No. So, just a quick recap. Why I'm speaking about this is that I've been a poor sleeper, and then started researching it. And if you actually want to read one book about sleep, read this one. Click on the link. It's actually quite good what comes out from there. the author of the book actually answered to my comment pretty funnily on Goodreads. And I started quantifying, and due to some issues other than sleep, but also due to sleep, I've been seeing a shrink occasionally and discussing sleep as well. And my shrink is telling me that the doctor should take his own medicine. I mess up my schedule all the time. I have a beer in the evening or 3. I do all the things that I'm not supposed to, and still complaining about. Sure.
I would ask, what those smart books say about day sleep? And really, you know, some kids recommend to go to sleep after their lunch and blah, but maybe.
Yeah, I mean, sure. Humans have actually always been sleeping 2 times a day. For a long time, for a very long time. It's just during the same industrialization era when they need to stay in the factory the whole big day just to be more efficient. Then it was when we stopped sleeping the daytime nap. So we used to always evolutionarily have a long sleep during the night and a short sleep during the daytime. And people are actually also naturally falling into 2 categories. There are the morning larks and the evening owls. So some of the people naturally stay up later more easy and sleep in the mornings more easy, and some of them do the opposite. And that's also, I guess, from the hunters-gatherers times, when people needed to actually sleep in shifts to have the whole night covered. Some people go to sleep earlier, some people go to sleep later so that the fire will burn on the night. Somebody's watching out for the tigers, whatnot. So, but we always used to sleep 2 times a day, and that's why they also suggested for the kids. But just that the factory owners feel that we are more efficient if we don't sleep.
One question about melatonin pills.
Yes, melatonin pills.
Yes, how this works? It's not like simple sleep pills.
So melatonin pills are quite a natural supplement. It's basically just if you expose yourself to bright light, your body is not naturally producing melatonin enough. If you take melatonin, it will tell your body that it's dark. It's not a sleeping pill in that sense. It's not a sedative, but it's just letting your other parts or processes in your body know that now it's dark, that we should start getting ready to sleep, but it's not an automatic way to getting to fall asleep. And regarding melatonin pills, then if you feel that you don't sleep well enough, then I do recommend like a really small dosage, around 3.3 micrograms, not more. Most of the melatonin supplements that they sell are 1 or 10, or like this is way too much. Just start with a really small thing and try to get your body to actually produce it naturally, not supplement it additionally.
A follow-up question regarding melatonin pills. So, can it be a reason for natural secretion of melatonin to be compromised? So it's like the body thinks like, why do I produce my own melatonin if I'm getting it from elsewhere anyways today?
Yes, that's exactly the thing, that why should not take too much of it, that otherwise your body will stop producing it if you constantly every night take it. It's a good thing to do once or like twice if you really need it and you know it's the wrong daytime and you have been actually exposed to a lot of light, but you shouldn't be doing that constantly. Like if you want to supplement something, there is also a good article in the last slide from Ben Greenfriend Fitness, one of my favorite biohackers, who also he does all sorts of weird things, but one of the articles for deep sleep demystified or something like that, where he describes about that really well. Yeah, we have a lot of questions. Let's take it from the back.
Already, did it help you to improve your sleep quality?
I'll answer that next in a bit. So let's take this one.
jet lag. So does melatonin pills help with jet lag?
So melatonin pills don't help with the jet lag itself. Jet lag is overall your body compensates for jet lag around 1 hour per day. So if you fly 7 hours off, let's take the next slide. This is actually a really good place. Think more about your travels. So do you need to switch to the local time zone where you go to or not? If you go to West Coast states, that's 10 hours difference for 2 days. It doesn't make sense. Just go there, have the meetings during Estonian hours, fly back, and yes, you will be a little bit messed up, but not as messed up as you go there, get into the local time zone. Getting into the local time zones means you actually acclimatize yourself in around 10 days when you are in the local time zone there, when you can actually start feeling fine in the time zone there. That's usually the time that you need to fly back. So in that sense, if you fly only for a few days, just arrange your meetings to be for your current home, local time zone. If you know that you have a long drive ahead of you, try to sleep a little bit before, eliminate the sleep debt before you go somewhere. Or if you know that you have a long flight over the Atlantic, wherever ahead of you, maybe stay on purpose a little bit sleep deprived, that you can fall better to sleep on the plane. So these are just some small hacks to do for jet lag. Karel.
Yes, do you have any thoughts on other sort of sleep strategies? I've heard crazy ideas like sleeping 20 minutes at a time for every 3 or 4 hours.
I've also read about them, but they don't work in the long term. You still don't get the cycles enough, and like it might work for some time, but usually after a longer time you trial those, your body breaks down still. So not that great. Yes, Stanislav.
Regarding jet lags, what I found for myself working is that when you travel, for example, ahead of time. One example that I've been traveling to China, then I'm kind of person that just couldn't fall asleep in the airplane. It just cannot. And then it's normally like a night flight, and you fly all night. And then you're kind of there early morning, but it's kind of lunchtime or noontime local time. So what I did, I tried to kind of have a rest right away a couple times. It didn't work really terribly for myself. But one time I tried it. Okay, I kind of survived this day. I just accumulate this sleep pressure. I just went on a meeting right away. Had a very difficult meeting. Somehow survived it, and then went to bed like 8 p.m. local time. And then slept like maybe 9 or 10 hours, and then woke up in the local time very well refreshed, and it helped me super well.
Yeah, one of the options if you need to travel between time zones is definitely that you try to stretch your day to the natural evening there, and it's really efficient in the morning to start pushing your circadian rhythm into the local time zone with exercise, with proper food and proper sunlight. So that definitely helps it. But overall, your body acclimatizes around 1 hour per day. You might hack it a little bit to be quicker. We had a question from back there regarding quantification. So I use a Garmin watch that's here, my yesterday's sleep. And then I have, my friends gifted me a ring, Oura ring. And as you can see, one of them is saying that I slept 7 hours, 51 minutes, and the other one is saying I slept only 6 hours and 30 minutes. And I was in bed less than this one thinks that I slept. So, like,
Which one is which, though?
So this is the Garmin, that's telling way more, and this is the ring. As much as I've searched through the scientific researches regarding the sleep quantification devices, then at least last year when I first did the presentation for my employer, The Oura Ring was supposed to be one of the most exact trackers. It got 92% of the time it understood when you fall asleep. But being the most efficient and most precise tracker, it only got like 55% of the times when you woke up. And that was the most precise tracker. So most of the trackers work based on accelerometers, and some of them measure your heart rate. Yeah, I wanted to say pulse, but pulse is not an English word probably. So anyhow, heart rate and accelerometers, and they are not that accurate. And the place where they most suck is understanding when you wake up. But as we can see, for example, the Garmin watch did not understand one time that I woke up. But I'm sure I remember many times waking up, so this is way more accurate in regards of how much I woke up during the night. What I like about the Oura Ring is that in the mobile app you can actually click into all of these that are red. Well, you can click into all of them, it gives you some suggestions. What I don't like is that the suggestions are always the same. Oh, sorry. I was considering, I had the Garmin watch quite some time ago already because I do a lot of sports where I want to measure my movement with the GPS. So I already had sleep tracking. I looked into whether I should get the ring or not. I thought, I'm not bothering, but somehow my friends thought that I definitely need one, being a sleep enthusiast. So now I have two things. I'm actually really glad about the ring because it gives a little bit better insight into sleep. It is a little bit more accurate. The concept of the ring is that actually if I wake up, of course I know how I feel, but if I want to look into the metrics, I open the app and I can look at only one metric. It gives a thing called readiness score. And based on that metric, I already basically know what should I do today or what should I not do today. So it's a number from 1 to 100. If it's around 50, I should not go to the gym. I should walk slowly. I should not try to do anything that needs a lot of brain power. If I'm around 75 readiness score, usually my activity score is really good. That's the physical activities, and my sleep score is the weaker part. And the readiness score basically consists of those two scores, but it's also based on heart rate variability, how fast your body temperature cools down in the night, and well, basically there are a lot of things in the algorithm, but I love the convenience of just looking at one number and knowing what should I do. 3 weeks ago I had a readiness score around 60, but it was a first day, and usually on first days I go to the gym, and I thought, I still go to the gym, and I couldn't go to the gym 2 weeks afterwards because I did my deadlift in a wrong way. I think I was just exactly a little bit too tired and didn't pay attention to how I hold my back during the lift, and just wanted to get it done, and it paid, I got my payment. So I mean, it doesn't, in the long run, it doesn't matter how you quantify. It's the baseline that you compare it against. Like, it doesn't matter what kind of tracker you have, but any tracker could work. So, Jeff?
Yeah, I wanted to ask about heart rate variability you mentioned.
Yes, heart rate variability.
Maybe elaborate. Like, it's a thing that trackers nowadays mention.
How over time am I?
Quite some.
Quite some.
Yeah.
I'll take your question offline, and I'll take the rest of the questions offline. Thank you for your time here. Thank you for getting me here, and it's been a pleasure.
Thank you so much. Always great to have you. This is to you from us.
Thank you.
Workshops. Regular one. I think that's it. Thank you so much for joining us. Veriff, thank you so much for being such a great host. And see you in a month. Stay tuned for updates.
I'm